Okay, I'm recording. So hi there, Ethereum community. I'm Dan Finlay, and with me are a number of esteemed experts on the field of MetaTransactions. MetaMask recently sponsored a MetaTransaction hackathon because we wanted to help promote a kind of generalized MetaTransaction solution. And through it, we learned a lot about MetaTransactions. We brought together a lot of people who have done incredible work on MetaTransactions. And out of that, I became aware of a lot of standards that needed promoting to the wider ecosystem. And I think a lot of people don't understand how Ethereum currently could benefit from some of these proposals. And so we brought all these people together to talk about the future of MetaTransactions, some changes the blockchain may need, some contracts we may want to standardize, and how wallets can integrate. So without further ado, let's go around and meet the panel that we have. So I'm Dan Finlay. I'm a co-founder of MetaMask. It's one of the first dApp wallets. We let people log into the dApps, and today you have to have Ethereum in every MetaMask account. But while MetaMask strives to support contract accounts, which we think is great, we think there's a lot of room for every account to be able to support MetaTransaction. Ronan, would you like to introduce yourself?
Yeah, so I'm Ronan. I guess I am like basically a dApp developer since one of the early actually MetaMask user as a developer. And then now I'm involved in several projects. The one that brought me into the MetaTransaction thing was the Sandbox, like a blockchain-enabled game platform. Yeah, that's me.
Cool. Yeah. If you were an early dApp user, you might remember Etherplay. It was like asteroids for your browser, and you could, if you won the high score, you'd get paid out. I think I broke even playing Etherplay by Ronan. Patrick, could you introduce yourself?
Oh, of course, yeah. So my name is Patrick McCory. I did a PhD in Bitcoin and Ethereum from 2013 onwards, and I recently left university to pursue a startup full-time called AnyDot. The way we got into MetaTransactions was that we were first building watchtowers for layer 2. So if you go offline, there's this watchtower that will respond on your behalf. And then I guess late last year, we realized the core component of that is a relayer. You can just send transactions to the network. So we thought, well, actually, this is really useful if we could outsource this as a service. Then we went down the MetaTransaction route as a way to do that. And so now we've been building this MetaTransaction relayer effectively. I've been working with Chris on that as well.
Cool. Then, Chris, you want to introduce yourself then?
Yeah, sure. I mean, basically what Pat said. But I've been working with him for maybe close to 2 years now. I did a bit of research with him while he was still teaching at university. And then, yeah, we worked mainly on watchtowers and layer 2 up until recently, I'd say about 6 months ago, when we started really trying to productionize a relayer.
Awesome. Hadrian.
Yeah, hello. So I'm a research engineer at iExec. I joined iExec after my PhD in distributed systems, and I started building their protocol and most on-chain part. So developing on smart contracts, and I trying to make this move from distributed system to blockchain-based dApps somehow. And yeah, MetaMask has always been useful, but it was always a limitation to, like, we want to onboard application and onboard like small IoT devices that don't have MetaMask. The question was always how to abstract this connection to the blockchain. And this is where MetaTransaction felt like the right way. So I spent a large amount of time studying this subject. Not sure I'm an expert on that, but I've got like a very strong vision of what I think MetaTransaction should be used for and how it should be constructed.
Cool, thank you. Laraz.
I'm an ex-Bitcoin maximalist that got into space a while back, running the first block store for Bitcoin. And then I met people from the Ethereum community and realized that the values were very different and more aligned with my own. So I became a lot more interested in what was going on. And last couple of years, we had a company that was building a contract custodial product. And the problem we had was, how do you interact with this thing for multiple participants? And then you would have to maintain ETH balance for all these participants, and it gets very cumbersome very fast. This is how we sort of ran across the MetaTransaction problem. And then Yoav, our CTO, a former CTO, because the company no longer exists, came up with what later became the GSN, and we decided to open source it. And right now I am helping with sort of high level strategy and communications for the Open GSN team, which is developing GSN as an open source project. And I will let Yoav introduce himself.
Hi, so yeah, I'm Yoav Weiss, and I'm working with Liraz. We used to work together on Tabuki, and more recently on OpenGSN. So I've been doing security, developing security and cryptography stuff since the early 90s. So I'm an old timer, and So I developed a few interesting systems over the year. Founded a few companies, most recently I designed the GSN, which is a decentralized MetaTransaction system. We focused on the game theory of how to keep everyone incentivized in a trustless system, where where you have incentivized relays. And the more demand there is, the more robust the network becomes by incentivizing people to run more relays. So this is described in EAP 1613, and now with the Open GSN team, we've been working on GSN2, which extends these capabilities and make it much easier to use and much more robust.
Cool. Yeah, thanks. Thanks for the intros. And it looks like everybody kind of explained a little bit about their motivations for working in this. I did have a section where we could maybe talk about any extra goals that we had for MetaTransactions, but I think we kind of covered that. Unless anybody else wants to add to what they think, just to revisit and rearticulate for any viewers, the prompt of the hackathon, and I think the topic of this, is to allow MetaTransactions for any account at all. And this has a certain problem because when a contract receives a message, it has a tx.origin and it has a message.sender, but the message.sender is just the initial contract that called in, and the tx.origin is just who paid for the gas. And so we have no way of disconnecting who paid for the gas from who authorized this message. And so it seems like every single entry in the hackathon used what we call now the message sender trick. Did anyone not use the message sender trick here? No, okay, everybody used it. So the idea is, instead of referring to message.sender directly, we create a new, we add some bytes to the end of the call data that represent the person who authorized this. And each contract that wants to be compatible with these generalized MetaTransactions needs to check those bytes to authenticate the message if they want to accept these. Is that?
If that's the definition of the trick, then for the submission I did, it was actually a different way of doing it.
Okay.
Which, yeah, I mean, I think the message sender trick is better, but the one I chose for the submission was simply to check the first parameter of a function. So you had to, it worked with mostly most standard because they have a from field, but it's, for some case, you had to make a special variant of a function to make it work. Yeah.
Right. So yeah, so every contract needed to implement. Oh, so it needed a special variant for, not for every function, but
not for every function.
submitting.
For function that, an example is approve of ERC20, or yeah, approve for 721. You had to make a variant approve for, and also approve for, and then the first parameter will be the thing to check. And so basically the receiver will, instead of checking the last 20 bytes, it will just make sure that the first parameter is the address of the signer.
Right. So putting it as the first parameter versus at the last 20 bytes.
Yeah.
But the point is, it's being added to the call data, and the contract needs to use this new source instead of message sender. Is that let me just ask everybody, is that a sufficient solution, or should there be like an Ethereum EVM change to separate gas payer from authorizer? Does anyone have opinions there?
I can jump in if you want. There's two things I want to say. So the first one is that whoever came up with that deserves the hackiness award. I think it's so hacky and beautiful at the same time. It works really well. I think fundamentally there should be an EVM change. So I've been thinking about it a lot recently, and I think really what we need is just a new dot call. So we have like static call, delegate call, dot call. Was this need one where it's like signer dot call or dot signer call, where it takes in the replay protection, the signature, and the call data, checks the replay protection, and does a dot call out, and then you get message.sender for free. That seems like the most straightforward way to implement it. And that would probably follow that E2885 standard. I got the number wrong, 2825, I think, the one Ronan was working on. Something along those lines.
2585.
Code. Yeah.
Yeah, if I can jump in, I'll go even further, because like the message sender trick is nice when a smart contract is aware that MetaTransaction exists and that there is a relayer at a specific address. All existing smart contracts will not be compatible with any relaying mechanism. So that means that all ERC20s out there are not compatible. So my vision was that this is a nice trick, but I mean, we already had some evolution of the protocol, of the Ethereum protocol. I remember of EIP, I think it's 155, where basically in the beginning, there was no chain ID part of the transaction. So when you were submitting a transaction with a signature, it was valid on mainnet and on testnet. And this was a major security issue. So basically what's happened is that we replaced the previous signature with additional data, particularly this chain ID, and we add a signature on top of that. And so basically now you are signing what previously was an old side transaction. And I think we could replicate this mechanism and add an additional layer of signature saying, consider a current transaction, it's signed, so it's okay. But if you add an extra layer of signature on top of that, the node will still recognize it and send it on behalf of the first signer, but the second signer would pay for the gas. And if that kind of fork was added to the Ethereum, we would basically not need MetaTransaction at all, because they would be built in. And this design would be compatible with any smart contract out there from the very first one, including all the ERC20 that attract most of the traffic. So obviously there will be we need to add some incentive mechanism, stuff like what the gas station network did would definitely be useful, but I think it would be much more powerful than any message sender trick that we're trying to standardize, even though this is still a good move forward.
Yeah, I could jump in with that. So I guess the basic idea is that you want to, given an Ethereum transaction, you want to add an extra field or something extra you sign to say, the person who's given this signed command, that's the message.sender, it's not transaction.origin. You know, transaction.origin could become gas.payer, and then the extra field would say, this is message.sender. I think you could either create it there or just as a new EVM opcode that's a dot call. Both should give the same effect, except one would involve an extra dot call.
Yeah, I think, I mean, to everybody I interacted with MetaTransaction and stuff, or everybody agree that the best solution is a protocol level solution. And I think it's not only for MetaTransaction, it can be for other things. And there is a Wei-Tang who actually started to work on a proposal that I think is very generic. It allows to batch transaction, and the batch doesn't need to be from the same as the one submitting the transaction. So it solves the issue as well of MetaTransaction, but as well as more than that. I think there is lots of interesting things. There is also RSK that is doing, I didn't look into the detail of the proposal, but again, I guess the main problem is that it's very hard to push for change. I mean, I've been to a call for 1930, which tried to just solve a very simple thing, and it's hard to push. I don't know I don't know the side of the core developer, but I think that's why while the goal should be the protocol change, I think we should still focus on something maybe more achievable on the smart contract side. And then if this gets traction, maybe this will help push forward a protocol change later.
Exactly.
I think that's a. Yeah.
Sorry, go ahead.
Oh, I was going to I was going to use that to segue to the next topic, because I think that most of the work that we've done acknowledges that a protocol change would be ideal, just like Ronan said. But we have some solutions that work today. They just don't work for legacy contracts. So I think it's okay to just acknowledge that limitation and discuss what we can do with future contracts. Is there anything you wanted to tag on there before we change topics?
No, I was just I wanted to agree with Ronan that this is exactly right. We shouldn't be going around asking for protocol changes. This was our focus with GSN from day one. We knew that asking for protocol changes is a very big ask, and in order to get the goodwill required for adding protocol changes, we need to prove our value first. So I think at this stage of MetaTransactions, we should focus on proving the value to the community. And after we have proven this value, then it will be the time to start discussions in ETH research and to suggest EAPs. So in the meantime, in the meantime, the standards we should be submitting are ERC, not EAP. They should be interfaces. It's fine to propose interfaces, and I hope we can get them accepted. But anything that requires protocol change, we should postpone, I believe.
Yeah, I completely agree. And I think most of us do, having built solutions that do work today. When we don't have a protocol change, these contracts get the authorization identity from the message sender, or the message sender trick. But in order to get that, the contract has to trust who appended that data. And so I just wanted to talk a little bit about the role of the relay and kind of why it's important that we share a relay potentially, right? Because if we start promoting a standard where contracts integrate a relay address, are they not trusting that relay to define who is the authorized signer for every transaction?
Right. So I can start. The relay should be trustless, because it shouldn't be. I mean, since the relay is not part of a specific project, and I believe there's a lot of value in having a shared relay network that makes everything robust, just like we share miners across the entire network. So the relays should not be trusted any more than you trust a miner to deliver a transaction. And for that reason, you shouldn't care about who the relay is. You should just not trust it. And the way to do that is by creating a contract like Relay Hub, or a forwarder contract like the ones that we've been discussing recently, so that you only need to trust you only trust a specific contract address because you know it's well written, you reviewed it, and this address gives you the message sender trick, gives you the message sender data. So your get sender function, and you can see how it's implemented in GSN, get sender checks if the transaction came from the known address of the contract that gives us the message sender, then it trusts it. Otherwise, it just returns message.sender.
Right. Yeah. Sorry, I mixed my language. I meant the relay contract. So you called it the Relay Hub contract. So the contracts that want to support MetaTransactions need to, and I use the word trust, but they need to refer to a relay contract that is going to just be validating signatures, basically. So I'm just pointing that out. And that means that we have to have a kind of shared validation logic across well, we effectively have shared validation logic between any contracts that use that relay hub. So I think, yeah.
No, I just said that trust was exactly the right word. When you use it, you shouldn't change it, because the Relay Hub is as trusted as it gets, because it can impersonate any, for example, if you have an ERC20 contract that uses it, then whoever, if there's a bug in Relay Hub, if there's a bug in the trusted forwarder, then it can impersonate anyone and grab any.
We lost him.
Yeah, you have chopped out.
But if I can say something, I understand that the point of having a simple relay that everybody can trust, but history shows that this kind of endeavor often fails last occurrence was ENS registry that we believed was forever and that had to be replaced. I mean, there is always a potentiality for very small bugs in that kind of contract. And for the ENS registry, I don't think it's that much of an issue, but it's not hard-coded in many smart contracts. But in the case of our relay hub, updating it would be way more difficult. It would need all the smart contracts to either redeploy or get somehow upgraded. And so all apps that use this relay hub will somehow have to ask themselves, what do I want this relay hub to be upgradable? And if so, which governance do I want to implement? And I think many applications will have governance issue saying that we don't trust the relay hub to last forever. And so we need to build a mechanism to update it. And that will be a major issue, I believe.
So this also depends on how much complexity in this relaying contract. I think it's maybe best to avoid confusion and use separate terms. So we realized that, for example, in GSM, the first version, we had this giant contract called Relay Hub, and it was too complicated for people to really understand it. So we separated out the forwarding contract, which is something Ronan also did recently in his proposed standard. And we think that's the best approach. You have a tiny forwarding contract. It has the minimal required logic to essentially verify that the message sender, when you use this message sender trick, has been confirmed by the contract. So you don't have to re-implement the logic of checking the last 20 bytes that have been appended to the call. And if you get the interface for this forwarding contract right, then you could, I mean, it's much easier to future-proof it, but I think Hadrian has a good point that it's very hard to know what the future holds. So having some sort of mechanism where you can, there's a standard interface that you as a recipient of this forwarding contract have to implement, but you even if the trusted forwarder changes, then you would only have to change like the address of the forwarding contract that you trust, and that could be done with the government's parameter. You wouldn't necessarily have to redeploy the contracts. And the less code is in this forwarding contract, the better.
Yeah, I can jump in as well and give some context. So I recently discovered this messy sender standard. Maybe it was around the competition time, or maybe just before or after. It was around then. And I remember looking at the Relay Hub, and as you said, it had a lot of code in there to do with staking. I remember thinking, there's a lot going in, like there's a lot going on in here. I was thinking, what is the minimal thing? What's the simplest thing we actually need the Relay Hub to do in terms of authenticating the caller? And I guess based on the forwarder example Ronan was working on, the basic thing the Relay Hub needs to do is just check replay protection. You know, it checks the user signature, that they've signed the call data and the target contract. They check the replay protection to make sure it hasn't been, sent more than once, and then it does that call out. So I think it's really just making sure that we get the signature format right, and we get one or two nice replay protections in there that support concurrency, and we might get away with not having to do major changes in the future. Like, I couldn't really think of anything else that really helps us have to do except replay protection.
I mean, so when I started to do the 2585, the goal was to make it as small as possible. Yeah. But then I realized, one, we wanted to be flexible enough, because we don't want to be in the same situation as we are now. Like, oh, I wish the protocol had thought about that. So the current version of 2585, I think, encompasses all the features we need to make it extensible, but that obviously make it that is not as simple as it sounds. Like, for example, it deals with account contract. I mean, this is maybe optional. It deals with message value, so you can forward the message value. It deals with replay protection, and it also deals with the ability to be extensible, which is the inner message hash trick. And then it also checks for chain ID. And then it uses the 712 EIP message format. Again, this adds complexity. And then another one that it does is batch capability. And I think, I mean, most of them are actually necessary. I mean, but for example, batch is important because if you don't do batch at that level, you have the issue that if you do batch at a high level, it means that the individual message can be sent independently, which breaks the batch layer, sending only one of the message of the batch. So I don't know how, I like the idea of simplifying to the thing, but I will never sacrifice flexibility. That's how I would see it. Like,
yeah, I think maybe it's actually worth taking the time in this call to go through some of the options that could or could not be involved. And one thing we're very conscious about is gas costs as well, to make sure that the overhead for MetaTransaction isn't too crazy. So for the any.sender stuff, we've tried to have a gas cost around 50K overhead, but that's not including the replay protection. So ideally, we really want that to be like 20 or 30K. Just to keep it minimum.
Yeah, I wanted to add in one other thing that could be extensible, but again, it pushes against the gas cost thing. So we've got the replay protection, we've got the batch support, but if the relay contract is also doing signature verification, it's also an opportunity to basically introduce custom account authorization. So effectively, the account abstraction that there's been so much long-term writing about.
This one, I mean, is a tricky one because you have to either have a DAO to decide how do we check which contract is allowed to check signature. Because if you pass in the call whose contract is allowed to sign, I mean, then anybody can basically cheat unless we have. Yeah, no, I mean.
I took some inspiration. Patrick had done a modular replay protection where the message would specify a contract that would enforce its replay protection. And so if you took a similar model, then anyone could just refer to a public generalizable, or, just a general purpose, authorization contract. So there could be many authorization contracts.
But these need to be trusted. That's the issue. These need to be trusted because they are the ones verifying the signature.
Yeah, they would have to be incredibly well audited, and right, they would be signature verifiers.
No, but also the forwarder will need to have a whitelist. So it means that we have a DAO that decide which one will be accepted or not. That's.
I think there's a subtle point here. So for the replay protection, that's easy enough to outsource. The verify signatures, like authorization of the transaction, that's harder to outsource because you could call out to a contract that always returns true. So it's actually difficult to outsource a signature to another contract, but the replay protection seems to be okay. Whether this was, executed twice. I only noticed that was like a subtle point I came across recently because I was trying to do a signature authority as well. And I was like, oh, wait, signature authority doesn't work.
Oh, okay. Good to know. Good to know. Yeah, that one's definitely out of scope. I don't think it's in any EIP. I just wanted to throw it past you all since I had you on a call. Okay, so we just talked about the core features of a relay contract, the balancing between simplicity and extensibility, enforcing replay protection, adding batch support. Maybe we could talk a little bit about some of the custom replay protection schemes that we've thought of. I think it's pretty cool. Patrick, your entry in the MetaTransaction kind of focused on modular replay protection. Do you want to talk a little bit about that?
Yeah, they're mostly Chris's ideas. I just wrote it up for him. Chris, do you want to talk about it? Is he listening?
Yeah, I can do. I think we did one that was similar to the one that Ronan is doing as well as his based one into 2585. We called it a multi-nonce one, where you basically have an index which selects the nonce that you want to use, and then that nonce you have to increment by 1 in the same way you do now. So this gave you the flexibility of being able to send transactions concurrently by choosing a different index, or by sending them in order by choosing the same index and then incrementing the second nonce.
Yeah, maybe a good way to visualize it is that you have like several queues and you can just jump between the queues as you want. You can have 10 queues and you just say, well, I'll send 10 transactions here, then jump to another queue. Then you get that concurrency. You get, 10 concurrent transactions.
Yeah, so the storage costs there are like linear with the number of concurrent transactions that you would do at your max concurrency, basically. Because once a transaction has the number of confirmations, then you might be happy to start reusing that, like that nonce again, that index again. We also had one for which we called bitflip, which was linear in storage, but linear with a small constant. So for every replay protection, for every transaction, we would use a single bit as a replay protection. And I think that worked the same way. Basically, we would turn a single bit from 0 to 1 in the nonce, and then we would increment an index when we filled it up, and then flatten everything back to 0 again. Then Pat also had one which was around what was it? What was the other one around?
Ordering. So I guess just to complete that, so for the bit flip, the idea is that every uint becomes a bitmap. And so if you want to send 250 transactions out of order, you just flip the bits. And you just check how's this bit been flipped. So what I was working on was bit flip ordering, where you have this, you fill all the bits here, you increment the nonce, and then you just delete this or restart it. So it just reduces the storage cost to 1 uint at all times. But then you can store a maximum of 256 transactions at once out of order.
Yeah, so there was an issue with that, which was that once you get to the end of your period, you can't broadcast any more concurrent transactions because you need to wait for the last one to get confirmed before you can zero everything out. So then what you can do is like pick some fixed number of of sets of these bit masks, say like 5, and then you can do like a rolling update through them such that like you can always move into the next index. You don't have to wait for an index to be like confirmed before you clear it. So I think so that one is like, again, I guess it maxes out as like, well, that one allows you like storage of, I don't know, like, yeah, the constant is even smaller than multi-nonce because it's the number of concurrent transactions divided by 256 is the number of indexes you need at any one time, right? Or something like that.
Yeah, so I guess you could summarize so we don't take too much time. The first was multi-nonce, so we have several queues. I know every index is the queue number, and then you just add an item to the queue. The second one was bitflip, where it's you get a bitmap, which is a uint, and you just flip the bits every time you send a transaction. There were the two core ideas behind them. One was to support maybe 10 transactions concurrently and have some ordering. And then bitflip was just, if you're doing 1,000 withdrawals, you don't care what order they're processed in. So you just throw them all out there and they'll get processed in any order. They're the two basic ideas.
Cool. And batch transactioning is easily and safely extensible, right? Under a relay that just points out. So those are a few cool opportunities, and then there's probably other ones out there that are possible. And so it's really cool that that's already just achievable with a current minimal relay that we're talking about.
Yeah, and actually for the multi-nonce stuff, it actually takes the same storage as the nonce. So if you think about replaced by nonce, just increment the counter by 1. You have a mapping from address to uint. So all we do is, instead of address, we have a bytes 32. So we take the assigner's address, the index number, and hash it, and we just stick that up there. So it's the exact same storage cost, and you have multi-nonce out of the box, which is really nice.
Nice. Does anyone else want to comment on replay protection? Okay, I wanted to, well, yeah, go ahead.
Yeah, I was just going to say, it's an example of gas versus simplicity, because, for example, all these replay protection are really cool, and we basically would like to have all of them. So we could either decide to implement all of them in the forwarder, and so it's optimized, or we could delegate them as different contracts, and then in which case you lose a bit of gas by having to call them.
Yeah, one thing I wanted to ask, so I'm not empirically tested this. So the way I've implemented it now for our little example is I built in bitflip and multi-nonce. So what it does is if you choose the replay protection authority addresses all empty bytes, then those will be multi-nonce. If you have a real address in there, it'll jump out to the replay protection authority, do what it needs to, and come back. But the main cost is encoding and decoding. But I don't really know how expensive that is. I just know it is expensive because obviously you need to encode the replay protection, then decode it at the contract level, which is some overhead, where really you could just pass in 2 nonces, but then you wouldn't be as flexible. I don't actually know the overhead of doing that. Maybe someone here has better insight in terms of is encoding expensive.
I mean, just regarding the gas cost, I realized just now that I think I will favor anything except apart from gas. I will put gas costs as a low priority because at the end of the day, we just mentioned before that the end goal is to have a protocol change. So in that case, we could probably have an hard fork that optimize all of this out later down the road. So maybe if we could like choose between gas and flexibility or gas and I don't know, ease of use, I will favor like the other one and not gas.
Cool. Yeah, that makes a lot of sense. And I think that gives us a good frame to have those conversations. Is that a particular EIP? Is that part of 2585 maybe? We'll come to that in a little bit.
Yeah, we're running implemented multi-nonce in that EIP. Slightly differently, but it is there, which is quite nice.
Well, maybe we should talk about that next. So EIP 2585 is Ronan's current proposal, or I guess it's an ERC proposal for a minimal forwarding contract. I think it resembles everything we've talked about so far. Ronan, are there any other differences that you would want to highlight about it?
I mean, I guess, yeah, I mean, the main thing is actually Patrick's idea that triggered me to look at it was the idea that we could have, yeah, the fact that it's minimal, but it still allow anything to be built on top. So it's the nice thing about that for me is it means that we can explore more complex solution on top while being able to start to build a contract with a trusted forwarder. But obviously, we mentioned already that the belief that we will have a trusted forwarder, I mean, it means that, I mean, depend on the fact that this forwarder needs to be foolproof. And it might not be humanly possible depending of the timeline as well. I mean, we might rush it and we might make a big mistake or something. So, but still, I still like that goal because I don't imagine even 1 year down the line, I don't imagine we will have the perfect relayer that will ever exist. So I think even if we accept that 2585 or whatever might not be the perfect solution, it might still be better to have a base forwarder that allow extensibility than trying to reach for the perfect, most complete forwarder.
Cool. So maybe it is important to also talk about kind of a road forward. So that almost makes me want to briefly talk about wallet support because as a wallet, you know, when somebody, let's say somebody's on an application and they sign a MetaTransaction, they give it to us. We need to know which forwarder to pass it to. I guess the forwarder is defined by the contract, and so there might be room for a standard where a contract defines what forwarder it uses. That would be a really nice thing to be able to look up just as a wallet. Just throw that out there. Maybe I'll open an ERC for it. Because if a contract can specify its relay, then wallets could just check that. Does that sound reasonable?
Yeah, so we've been working on that with Ronan and Hadrian and coming up with this tiny standard for what supporting MetaTransactions looks like on the recipient contract side. And we think, you know, we have sort of a draft that we're working on together, and we think we can make it simple enough so a developer doesn't even necessarily have to understand all the complexity that's happening inside the forwarding contracts, just like the minimal part. And we're going to test this out hopefully soon at the next upcoming ETH Global Hackathon. With regards to batching, we have realized we've been working on this and trying to come up with a generic universal solution. And it seems that there are trade-offs inherent to doing batching. So one of the ideas that we've been exploring is maybe having sort of minimal trusted forwarder contract that that verifies the message sender and the nonce. But if you want batching, not every application does. You could use a separate trusted forwarder that inherits from that basic one, and then it just supports batching as it's like an encoded array of function calls. And then when you look at the forwarding contract, essentially it's derived from the basic contract, but it doesn't have the functionality required for batching. So you can separate that out. And in a recipient contract, it would just be like, okay, I need batching, so I want to support both these forwarders. If you want batching, you go to me through the forwarding batcher, a batching forwarder, and if you don't want batching, you can use something simpler, so you don't have to audit the extra functionality.
Yeah, that sounds great. And so Ronan was saying how this forwarder kind of supports any iteration on top. And so I just wanted to check where I was like, coming from gas station network, this basic forwarder is able to support relays that are paying gas for people.
Yes, of course. Yeah. So yeah. This basic forwarder, you could build on top of it. For example, you could plug in pretty much any type of relay system, whether it's centralized or decentralized. And this addresses the main complaint that we had with GSN, where essentially you have this monolithic giant relay hub contract that's not only serving as a trusted forwarder, but also as a decentralized relay registry, where anyone that sets up a relay, they can register, and then anyone else can use it. And that was complicated for people to understand. And before the network is up and running and very robust, there's not a lot of incentive to use it. So you have this catch-22 where, yeah, if the network exists and there are a lot of decentralized relays serving all the dApps, and it's great for everybody. But before that exists, you have to pay to understand this extra complexity, and maybe it's not so attractive. So what we're trying to go like with the next version of GSN, we're trying to go like in the extreme opposite direction. How do you achieve the same results that we were going for before, but with a set of minimal composable contracts, and then figuring out the interfaces between them. And yeah, for something like the forwarding contract, ideally that would be something that not only a GSN could use, but we want to work together with Onan and Hadrian, anyone else that's interested in this problem, to come up with that minimal forwarding contract that then you can plug in like any arbitrary MetaTransaction system.
I guess the main difference here will be that 2585 try to have only one minimal forwarder, while here the solution you are thinking of is more like they all have the same interface, but the contract developer need to choose or need to have a mechanism to change them as they want to choose which one they pick, right?
So it's not really a difference in terms of what we think would be ideal. We think at least for the minimum functionality that you need in a forwarding contract, trusted forwarding contract, we think it would make sense to have one global contract if that's achievable, and we can agree on what the scope of functionality is and what the interface should look like. But we recognize that it's going to be maybe very hard to future-proof that. So saying, okay, this is the standard forever and ever, that's a bigger ask than saying, here's the interface that you should support as a dApp developer. And also dApp developers, especially before they actually deploy their dApp and need to decide which trusted forwarding contract to trust. They don't need to know anything about how the forwarder works. Like they just need to know about the interface that you need to implement. And then if you agree on the interface, then from the dApp's perspective, that would be just, okay, so maybe I just go with the default that everyone seems to agree with, but then maybe in the future, I need something else. Maybe I need batching, and batching is not a feature supported by like the basic forwarder. I mean, really, you have to decide on what the minimum functionality for a forwarding contract is. Maybe I want some extra bells and whistles, and then I can choose to use something else, or maybe that could even be a governance parameter. So I think it still would be ideal to form consensus around, okay, like, you don't have to audit this contract separately. We have audited, if you want this basic functionality, you would just default to this a trusted forwarding contract, and everybody has sort of agreed that it's a good implementation for the basics. And then maybe you could say, okay, but you have another option of using something that has like a slightly wider scope of functionality. And if you want to implement your own trusted forwarder, then you can do that without like, changing your DApp. You just have to point to a different trusted forwarder. But we wouldn't recommend that, because having too many degrees of freedom that are unnecessary is probably, it gives you more freedom as a DApp developer, but it also, it's another decision you have to make, another thing you have to understand. And if you have a safe default is a much better development experience, especially for people that are new to the ecosystem. So I think that's still the best way to go, having like agreeing like, on one sort of default trusted forwarder. You only change that.
I would even go a bit further with that. So what we're going to do tomorrow is release a competition that's going to use a minimal forwarder just to show how it works. And I think what we would really achieve is that if we all agreed on a contract that would work for the next year or two until we have until we work out the real requirements that we need, you can actually build a client library around that as well. So then as a DApp developer, all you need to do is call a function that says assign MetaTransaction. It would, look up the replay protection in the relay hub, grab the latest nonce, it would sign the transaction and come back with a nice packet. And then that packet could be given to the relay service. So for the GSN case, you'd wrap it within whatever GSN wraps it in. So then there's one standard for signing meta transactions, which is basically the call data, the replay protection, and the signer.
Yeah, exactly.
It's much better for the developers as well, because they don't have to implement.
Exactly. And this is something that the developer experience, also like on the client side, making the clients really easy to use, is something that we've been putting a lot of effort into, and hopefully this week people will be able to try it out. We want to get feedback at the next hackathon. Our approach is just to hack the provider, so it's completely transparent. Like if you use this provider, then it just works. And the provider can, you can configure that. It could be an advanced provider configuration if you want, right? But there's just something that works out of the box that you don't even have to think about. It just works.
Yeah, I think Chris has been working on that the past few days as well on our side. I don't
know.
Oh,
we should sync up then.
Yeah.
Yeah, one thing I have, I've got this trade-off there between security and ease of use, I guess. I mean, it's a classic trade-off, isn't it? I mean, so if I have access to the user's private key, well, to a wallet, basically, then I've got a lot more power to make choices in how, in sending, making it easy for them to use a MetaTransaction client. But if I don't have access to a full power of provider, then it makes it harder for a DApp developer. So an example of that would be on a Web3 provider. You might have a contract that you just say, choose a function and do .send. And if you have access to the wallet that will sign the stuff for you on demand, then that will just go straight to the relayer and go on. But if you don't, then you need to create all you can do there is create the relevant data, pass that back to the user, or pass that back to whatever wallet functionality and request the signature in that way, or back to the DApp developer. So I wonder what you guys think about that trade-off actually. Have you covered that or?
I think it would be best for you all to take this one, on our end at least. So.
Yeah, that's a great question, and we should definitely continue that conversation. We're coming up on time, and I really wanted to make sure that we gave a moment for EIP 1930. Ronan devised this for solving a problem related to how gas usage works between the relay contract and the contract that's being invoked. Ronan, do you want to give your lightning pitch of 1930?
Yeah, so basically, actually, that's a nice thing I like about the minimal forwarder, is that you can avoid this issue, which is another argument for actually focusing on that part and then let the protocol update with the gas, because basically 1930 fixed. So in current Ethereum, the way gas, when you give gas to a call, you actually don't give any gas. It's a maximum value that call can see. And so it could happen that you actually give 0 gas or at least 1 gas. And so the receiver will error out, and there is no way to know that it error out because there was not enough gas or not. And so if most developers assume that actually in most MetaTransaction implementation today, they all failed. They all assume that there was enough gas there. And in many cases, it worked out because they do some operation later that will have failed if there was not enough gas. But because of the rule, there is a rule introduced in EIP 150, which left 164 of gas. So if the call that you are making spend a lot of gas, let's say 6,400,000, then you will have 100,000 left. And this will be enough to do most of the thing MetaTransaction do. So then you are in the situation where you check the gas left and you assume that it will be enough, but actually it was not enough. And so the relayer could maliciously make the transaction fail and get the reward for it. Does it make sense? Or?
Yeah, I'm sorry, Ronan. I don't really understand. I mean, I used to after a transaction potentially fails, look at whatever gas is left, multiply it by 63. And
exactly.
if that is more than what I required, I assume that enough gas was provided. So you are saying that even if that value multiplied by 63 is bigger than the requirement?
No. I mean, you should read the issue. I exactly mentioned that solution. That's what I used in all the MetaTransaction implementation I made. I use that.
That's something I'm using. So this solution is working, right?
Yeah, but nobody is using it because everybody, I mean, except you and a few other, and Patrick. But if you look at all the current MetaTransaction implementation, Gnosis Safe, all of them are actually have this vulnerability.
So this is also something that we ran across and have been thinking about from multiple directions. And the solution that we're going to try and use to solve this problem is to encode the gas limit as part of the meta transaction. And this you can obviously lie about the gas limit, and then that's a problem. But I mean, if you have a staking mechanism for relays and you let the relay calculate the gas limit and post it as part of the meta transaction, and it's very easy to detect the relay lied about the gas limit for the transaction. So we were just like running against. The reason that we ran into a lot of reverse with meta transactions is it's very hard to calculate remaining gas left from within the transaction, and we kept running into differences between how it was supposed to work and how it actually works in practice. Very weird bugs. And then it seems that they're just like encoding this, trusting the relay to the degree that it has the incentive to post the correct gas limit. Seems to just be a neat way to solve it.
Yeah, actually, I also want to point out that even the 633 trick, I personally don't like it because it's dependent on 150 not changing, and also it's actually not foolproof. So if you have if you add a method, like for example, Patrick, in your solution you use require, and if you should use assert, because when you use require, it means that if someone was calling a meta transaction in a meta transaction, the require will fail with not the full gas, and the 63 check will fail here to safeguard you from making sure. So I feel it's an act more than anything, and I think the proper solution is really to fix it at the EVM level, because it's what you expect. Like, when you make a transaction, when you specify the gas limit, is the gas that you actually give to the transaction. And when you make a call, the gas have a different behavior suddenly. So for the developer, it's weird. It's like, and that's why, yeah, people fall in the trap basically.
All right. Well, we're right against the hour, and I unfortunately have to move on. But I want to thank you all so much for coming together and sharing all these great ideas. I hope that we continue these conversations over in ERC 2585 and 1930 and any other numbers people want to give shouts out to, so we can all do homework after the call.
Well, one thing I'd like to mention is we're sort of trying to bring everyone that's interested together to create a series of standards. And before publishing the ERCs, we're just like, we have these very loose drafts that we ask for comments on. So Onan and Hadrian and Yoav, we should have the first one of these drafts. And then we'll be very glad to get as much feedback on it as possible. And once sort of like everybody agrees, yeah, this is the way forward, we haven't missed anything, then it might be like easier to form social consensus around it and get like, just, okay, this is now just another ERC number, but something everybody recognizes as the way forward. So feedback.
Where can we find those?
Appreciated.
Yeah, where?
So this is going to be something that is ready for review, I think, as soon as Onan and Hadrian sign off on it. Maybe like in the next couple of days, we'll circulate it to that. Maybe we can circulate
we've got like
that
viewers. Let's say we've got viewers, you know, because we're going to publish this video. If people want to participate in the conversation.
That's a great question. I guess, yeah, we're going to be setting up new forums for the GSN like community. So part of the discussion could be there, but we don't even have that set up yet. We're just like focused on development. So
okay. So yeah. So follow Laraz on Twitter. I'll try to tweet out about it. We'll definitely tell you what, post links to that on those EIPs that we mentioned. How about at the very least? Yeah. So this can be a kind of gathering ground.
Follow Dan on Twitter, and then he'll post a link.
Yeah, among all my other garbage. You just have to wade through.
You have two accounts, so which one?
Yeah. You'll have to figure it out. Cool. All right, thank you so much, everybody. Any closing thoughts? Cool. All right, well, thanks so much for all your great work. I can't wait to have this all live in wallets everywhere.
Perfect, thank you.
All right, thank you.